Okay, so this first tutorial video is going to help you to understand how to do that first team challenge that we did on the first day of class. The question has a lot of information in it, but there's really only two pieces that you need. These are the pH is 6.8 and the diameter of the cell is equal to 0.66 micrometers. Okay, the easy part of the question is to figure out the hydrogen ion concentration given a pH of 6. We need hydrogen ion concentration equals 10 to the negative 6.8, which I can do on my calculator. And I get a value of 1.58 times 10 to the minus 7 moles per liter, or molar. The trickier part of this problem, though, is really to figure out how many liters are in one Prochlorococcus cell. To do that, I have to know what the volume of the cell is. Prochlorococcus, fortunately, is roughly spherical, and we'll make that assumption. The volume of a sphere, which I know, or you can look up on Google, is 4/3 pi r cubed. So I need to get from diameter to radius. So we're going to say that the volume is equal to 4/3 pi times 0.3. Now I'm going to go to meters right now because micrometers are not going to be in a unit that I can work with. So I'm going to say 0.3 times 10 to the minus 6 meters cubed. I knew that the micro symbol is equal to 10 to the minus 6 of something. So when I do that calculation, I end up with a volume of 0.3 times 10 to the minus 6 then I am going to cube that number, multiply by 4, divide by 3, and multiply by pi. And I'm going to get a volume, when I do that, equal to 1.13 times 10 to the minus 19 meters cubed. All right. Now, our concentration is in liters, not meters cubed, so I need to convert meters cubed to liters. I know that there are 1,000 liters in a meter cubed. It's going to allow me to cross out these units and get into liters. So I'm going to take that number that I got, multiply by 1,000, and I'm going to be at 1.13 times 10 to the minus 16 liters. That's my volume of a Prochlorococcus cell. That is very small. Now I simply have to multiply that number by the concentration of hydrogen ions per liter. And I'm going to end up in a number of moles. So I'm going to do that. My calculator will behave itself. And I come up with 1.79 times 10 to the minus 23 moles. Great. But it wants to know the number of protons. So I have to multiply by Avogadro's number, which is 6.02 times 10 to the 23 molecules per mole. And that is going to give me a value of 10.5775, sorry, dyslexic. Okay. That is the answer to the problem. If you're really on the ball, you'll know that you can't have a fraction of a proton in a cell. So we could say, on average, you have 10 to 11 protons in a Prochlorococcus cell. Use the same logic to figure out the number of protons in the oocyte, and you'll find that number is a whole lot larger because the volume of the cell is a lot bigger. That's it.